Weicheng, and I'm going to give a very quick status report update about Taiwan. And okay, we start this section in 2011, and my topic, my core concept is always utilization. So just go through this quickly. Still in 2012, still utilization, but we have different aspects of it. Now this year, we kind of move forward to the cloud computing and big data area. I will address a little bit more about this. And in addition, we have a student class challenge Vision Taiwan out south, trying to promote the HPC to the community, especially to the young students. Hopefully, they will become HPC scientists later on. And in terms of facility, we don't have much improvement over the years because the government is under reform, and so that might take another half or 1 year to settle down. But other than resources requiring, we'll work on something else like a resource program and a scheduler and all this, and also try to integrate a cloud environment with the big data application. I will talk a little bit more about that, especially like application center solution, VMware physical machine, and also the SDN. Now here again, we have to go through the pain of the resource we have now. Still, the biggest machine is the 177 teraflops, which is 4 years old. And the total capacity of the center is 288 teraflops. And we have proposed the petaflop machine to the National Science Council, which has now become the Ministry of Science and Technology, just established like 2 months ago. That's why we are frustrating about the funding resource. The total capacity of the storage space will hit 6.4 terabyte at the end of this year. And also, at the end of this year, we have 100 gig backbone domestically in Taiwan. And in addition, we have joined the global 100 gig backbone project already. So it depends. We are waiting for the U.S. partner to finalize their proposal to the NSF. And if we take a look about the utilization of our computing facility, I have highlighted two major increase in terms of percentage of use of the computing power. Like climate still keep growing. Right now it's 16% of utilization and keep growing. And the biology side, especially the NGS next generation sequencing, have come from, I think it's rise from 1 point something to 4.8 at this moment. So these are two big applications in our community right now. And in terms of storage-wise, again, you can see the gene sequence and also weather and climate simulation. They take a lot of capacity there. And this is what our research has done over the year to try to show the result. And from here you can see both the temporal and also spatial resolution are not quite good enough. That's why we need a bigger computer, which is out of our hand at the moment. And we need a better and accurate numerical scheme for this simulation, and also different scientific model might be needed. And here, I kind of summarize the demand from the climate, but I think I will skip this. Maybe you know all about that. For NGS Platform of NCHC, we have established ecosystem for gene sequencing simulation. And here, this is the architecture of it. We sort of connect our cluster, a large memory cluster like a node with 1 terabyte and 2 terabytes of memory, and also the high performance computing, all connect with 40 gig connection. And to the user, we provide 1 gig to their interface. And here are the tools available on the platform right now. They keep increasing. We kind of find all the available open source package and put on the system. So the national program, which is related to gene sequencing, can use this facility to do their sequence and assembly. And here is the Galaxy, which is available open source. It's not from us. It's open source system, and we kind of install our version here. And here is the demand from NGS. Again, I will skip this. It's just here for your reference. And I'll talk a little bit more about healthcare. Okay. Oh, by the way, there's a small, tiny application called Go Game. He's kind of Chinese Oriental chess player, and he kind of steer the computing cycle between large job and this kind of interesting thing. But from here we learned that maybe we should try to utilize the resource in a better way. Try to fit in small job in between big jobs, instead of have the whole system waiting. And thinking about the infrastructure, okay, we need to face the reality. So there's no one single system that satisfy all the demands and for all applications. There's no way to utilize the whole full capacity of a huge system, and budget is never enough. Okay, and it's beyond reach some of the time. Actually, sometimes it's shrinking. So we are thinking about to build our computing power, which we might end up with thinking about the application-based system design, which we will build a smaller computing power for specific application. In terms of, since we are core source about this utilization, so we don't really care how big it is. Well, of course, we are not capable of doing that as well, but we'll think about how we can utilize the computing power, okay? And utilization, okay, as I just mentioned, we have some applications to steer the cycle between big jobs. And so in order to do that, we want to have a meta schedule which can integrate all the different computing resources into one place, and can let the user, they can face only one user interface, and will act like just facing one single machine. But underneath, we actually integrate with the cloud virtual resource and also the heterogeneous computing power. And also, we have 100 gig backbone ready, including domestic and international around this year. So we'll really think about, should we move the data to the computer or move the computer to the data? This is argued between all these two models for a long time. And what we think about is maybe we should take both ways. For some application, you need to move the data to the computer. So that's why we have a data gateway under investigation, and also the VM approach, which will move to the computer to the data. Okay, so here I would like to address the SDN, software-defined network. Why we want to go into this area? Since we are going to integrate HPC with the cloud with the big data, but lots of time for the application, if the resource is spread around the different sites or different machines, you really need one dedicated or isolated network to connect all these resources together. That's why SDN come into play. And currently we have already established the SDN test bed within Taiwan, between our side to try to utilize the backbone. And also have an SDN connection to Japan, and we are currently move that SDN connection to the US at the same time to the Chicago and also to San Diego. It's under progress right now. And also, we have done two examples of try to integrate big data application with the cloud. This one is the university entry exam. In Taiwan, we have kind of one exam to decide who we're going to which university. I think more like in Japan or Korea. So what we did this time is, actually after written exam, we have interview material need to upload to the system, and that every university to look at this application. Okay. And here is, the data is not that big. It's only 1 terabyte level, but it's important. If you screw it up, you're going to end up putting yourself into disaster. So we kind of virtualize the service. We provide a dynamic resource allocation and try to minimize the downtime of this. And next year we'll try a bigger case with high school students, which will be like 3 times as big. And here is another program we are under investigation. It's eCells project. What it does, right now how they did it is they kind of have isolated physical space for the researcher to access this data. The way they access data is they give a hard drive, put into a local server, and you do your analysis there, and you can download the data and the data is delivered by FedEx way, which means you carry a hard disk, and data is always monitored by the data owner. Now, what we are proposing is, okay, move it into the cloud. It's nothing special, just regular cloud platform with a VPN and all those kind of security. And still, we have data center here. I would like to apologize that there are some Chinese character there. So on our network, we provide VPN connection for those analysis center to connect to our data center, which is in our center. And we sort of provided a cloud computing environment to these users. What it does is every user got one single virtual machine, and each VM is isolated and completely owned by the user. So they cannot connect to each other. It's kind of isolated any possibility of data leakage. Anyway, I need to rush this. What we're going to do next is try to still hold on to the concept of utilization of our cloud infrastructure for the big data and for data-driven applications. So here we need to integrate NCHC resource, and also we are thinking about the possibility to integrate the ISC provider's resource, which means we can, some of job will send to the Google, some of job will send to Amazon, things kind of like this. In order to do that, we are currently working on the technical issue like interoperability to deal with the heterogeneous system, and resource broker for different application based computing resource, and dedicated and isolated network like SDN. Again, we need to push the data through 100 gigabit level backbone. This is all. Thank you.
Okay, thank you.